All right, happy Tuesday. How's everyone doing? I was in Toronto running High Rocks. Anyone heard of that? Nice.
How'd you go?
It was fine. Wasn't great. Did fine. I had a goal. I didn't hit it. I will next time. But I got to hang out with Maxine at the finish, so that was fun. How's everyone doing? The weather was great this weekend, so I hope you got outside. I definitely did. Toronto's really lovely when the weather's nice. Let's see. So we have a mini exam coming up next week. It'll be on Tuesday, so a week from today. It's going to cover everything in part 2. So this is sort of data operations, the kind of things we've been working with. Next class, I hope to do a bit of review at the end of class. We're talking about merging data, which is like about as interesting as cleaning data. So we're going to spend the first part of class on merging, and then we're going to talk about some review topics at the end. Sound okay? Not a lot of big housekeeping things other than that. I haven't posted homework, let's see, 2.4 for today. That'll get posted probably later tonight. And then we'll do one more kind of small homework for merging data at the end of the week. Let's see. You all excited for the end of part 2? Once we get through part 2, we're going to start with the big topics for the class. We've spent the first part of the semester talking about really just getting familiar with working with data. So lots of like how we classify data, how we visualize and summarize data, and then in part 2, what we're doing is focusing on really just working with data, manipulating it, moving it around and such. In part 3, this is when we start building statistical models, and in my mind, anyway, this is one of the biggest concepts we have in all of the sciences. Like, we do a lot of statistical models in economics specifically, which have some particular nuances to them. But the core ideas, a lot of you are already a little familiar with, but extend much more broadly. So no matter what area of science you're interested in, the tools we're about to start building are really going to be foundational, as long as your area of science requires using data. So going out into the world and observing something, and then trying to understand what those observations mean. If your area of science involves that, what we're going to start building in part 3, and extending into part 5, will be that skill set. Okay, so that's where we're going. Get the attendance code if you need. Any questions before we get in? You all excited to be done with the first 2 parts? I think part 2 is like the big slog. I don't think it's. I've been questioning whether to do it this early in the semester. It's a lot of just working with data. One of the last big concepts we have, this is I think one of the more interesting parts of part 2, is what we call grouping data. So we're just going to go through and think about some decisions. I have a really nice data set from Starbucks, surprisingly. I know we've never worked with Starbucks data before, but this is a different angle. So we have data on the promos. So how many of you have the Starbucks app? I do. Every once in a while, they'll send out a ping. Like, you'll get a notification on your phone that there's a particular deal. And Starbucks actually keeps track of you and whether those offers are accepted or not used. And they have a record of everyone, which is part of what they're doing with these pings. Part of the reason they like the app, the reason they offer the app, is because they can keep track of which users are using which offers and using and buying which things with which offers. So they're actually using your behaviors to inform their decisions internally. So what we're going to do as economists is think about, some economists, think about business decisions and such. That's not like a super interesting angle for me. What is interesting to me is which one of these offers changes behavior the most. So one of the big ideas in economics is that people respond to incentives. So what we're going to do is try to examine which one of these offers is the largest incentive for Starbucks users. So we're going to go through and use this Starbucks promos data to get a handle on that. How is behavior changing with each one of these offers? So this is really maybe one of our first forays into thinking about behavior from a data perspective. And in some sense, we've already been working with behavioral data so far this semester, but we're about to start turning much more towards thinking about behavior in the context of data and what we can learn from data about behavior. Okay, so I'm pretty excited about this. If you want to take a look at the raw CSV file, that should be available to you. If you scroll down here. So I posted the notes as well, and you should be able to download the Starbucks promos data. Oh, I'll fix that in a second. That should be, I'll fix that before we get there. But we're going to mainly work in the notebook today, so you won't need the data set directly. This link should work too if you want to find where I got the data set from. But this is, I've done some cleaning to make it a nicer data set. What you get here is just the raw data. Your mileage may vary there. But you can click on the notebook to get to where we're going eventually. But for now, I have the header of the data set displayed in the slides. And so what you can see, we have three main rows. We have event, which is the kind of event that's being recorded. So this is a categorical variable recording what type of event is happening in the row. And the top ones here are transaction, but as we'll see, they're not all transactions. And then if there's any revenue recorded with the event, then that gets recorded in the revenue column. And then we also have a bunch of IDs. These are the different pings that are offered on with the offers. So, for example, 2 off of 10 is just if you spend $10, you get $2 off. Or BOGO 5 is if you spend more than $5 on something, you get something of the same value free. So buy one, get one free if you spend $5. And the same for BOGO 10. So if you're looking at this, I want you to turn to someone next to you. You're thinking about just trying to understand what's in this data set. What are you going to do first? There are a couple of ways we can go first, but I just want you to talk to your neighbor, tell your neighbor something nice you did this weekend, and then tell them what you would do to this data set to try to summarize it. Right? Like, this is not a great picture of the data set. Just the header doesn't give us any insight. What would you do to get some insight into this data set specifically? We'll take about 2 minutes here. Just say hello. Remind yourself that you are both human beings and exist in this world, and then talk about data. What are you going to do to this data set? 2 minutes.
Yeah.
Understandable.
If they're both, one is intermediate probability and the other is time series. And
Oh.
I missed one of the classes yesterday and
Yeah.
I will try to be here as much as possible today.
I understand the struggle.
Oh, yeah. I swear to God.
Okay, nice hearing all of your chatter. I'd love to just have you keep talking if you wanted to, but we have a lot to get through today. Someone tell me, what's one fun thing you did this weekend? Yeah.
My parents came down.
Nice.
Tailgate together.
Oh, that's fun. Good weather for that.
Yeah, it was perfect.
And then someone tell me what you would do to this data set to summarize it. Maybe a harder question. Ruby.
Maybe start by filtering for data through what offers, what offers
Okay, so yeah, Ruby's saying, look, we have a bunch of offers, and we want to maybe try to understand each offer separately. That's kind of what we're after in this class period today, is like trying to understand which offers are better than others, like which offers move behavior more than others. So one thing we could do is try to filter this. So we could go through and look at offer ID and then maybe filter just for 2 off of 10 and then maybe try to get some summary statistics for that. What else might we do? There are lots of potential ways of going here. Yeah, Darren.
So I was like directly compare them. I'll just average or I'll take the mean of each offer after
Okay.
separate them and then compare it to transactions that don't have like any sort of specific offer.
Yeah. So, I mean, one thing we could do is just look at maybe average revenue per transaction. And one thing Darren's pointing out here is this event column isn't only going to have transactions, but it will also have like non-transactions. So when the offer is sent out, maybe it wasn't transacted on. So we also want to sort of consider those things too, which we're going to spend a lot of time getting into the details of that. Yeah, what else? I think these are all really good places to start. I'm going to show you a figure that might be a bit helpful in getting started. But before we do that, and this is what we call grouping, which is essentially what Ruby and Darren were pointing out here. We want to get some idea of some measure of something or other based on each one of these categories in offer ID, right? We're trying to compare which offers are better. And so we want specific offer summaries. Okay, and we have this nice grouping feature that we can use. The general process we're going to use today, when we're trying to understand subsets using grouping, the first thing we often start with is a filter. So Ruby was pointing out maybe we would filter by some category, and that's often where we'll start. If we need to do some filtering, which we will end up needing to do in class today, we do that first. The second step is to group. So we might want to group the data, just break it all out by offer ID. And conveniently, there's actually a faster approach than what Ruby's pointing out with filtering. So we could go through and filter by group, but as Darren is pointing out, we can actually just break the data into a bunch of groups and deal with each of the groups at the same time. which makes our lives pretty simple. And then the third thing we're going to do is aggregate. So once we have the groups, then we're going to try to come up with summaries by group. And this is all going to be very nice. So this is grouping data. This is our general process. We have this large pile of data, and we want to turn it into something that's simpler and more easy to understand. This is a pretty powerful technique. The last step I mentioned is aggregation. So once we have our groups, we want to do something to it. These are just some of the common aggregation functions that we can use. So we're going to add up revenue in a second. We can also count how many rows there are by group. We can get mean, maximum, and minimum. So we're going to use at least 3 of these in our exercise today. Okay, so if I'm approaching the general question of which offer is most effective at moving behavior, I might break this into 2 sub-questions. The first one is, how likely is each offer type to actually be used? So if I'm Starbucks and I'm sending out an offer, how likely is that going to be picked up and actually used? And then the second is, if I send out an offer, what do I expect the average return to be? So how much do I expect the Starbucks customer to actually spend when I send out the offer? So these are 2 similar but different questions that we're going to try to answer. But we're going to open this up step by step. I'm going to ask you a bunch of questions. You're going to tell me what you would do, and then we're going to go through this step by step. Okay, so the first part, we're going to think about counting. And the main question we're going to try to answer here is, how frequent is each offer type in our data? Just a raw count. So the first thing we'll do is go through and try to count each offer type specifically. Offer ID is the categorical variable that just keeps track of all these things. And I think probably by now the link should be fixed. So if you want to actually go to the data set, this will eventually be fixed. There you go. So if you want to download the data set, you can take a look at it there. Okay, so if I'm just going through and counting offer ID, this is what the offers look like in the data set. So I'm just going row by row and counting up how many offers are coming in by offer ID. Okay, so what do we see here? What does this figure tell us for our big questions? Yeah, Jason. Yeah, so the most common offer ID in our data sets are the BOGO 5 and the 2 off 10. So this gives us some indication about frequency. What does this tell us? Maybe turn to someone next to you. What does this tell us about behavior change? So we're thinking about, how does behavior change when we receive an offer? What does this tell us about that? Take 30 seconds here. Okay, someone tell me what you're seeing here, and maybe what else might we need? Like, what do we see here? What are we missing? What else might we want? Yeah. Yeah, so all we're seeing, we're just going row by row and counting up each one of the offer types and then just listing them out here, which is informative in some ways, but it doesn't give us a lot of insight into behavior change, right? Like, it doesn't tell us which one of these offers is most effective. So what might we do instead? I mean, I just gave you a question on screen, which may give away the next step. But if I were looking at this, I would maybe try to go through and count up how much revenue is coming in by each offer. There are other things we can do, and we're going to do a bunch of other things. But I think this is maybe a first place to start. So I'm going to give you a figure. How much revenue does each offer type bring in? All we have to do is go through, group the data, and then add up within each one of the groups how much revenue is being brought in by each one of these offer types. And that looks like this. Okay, now let's take 30 seconds again. I want you to talk to your neighbor about what this is telling us about behavior change and maybe what else we might need. This is better. All right, 2 questions for you. 1, what are we learning from this figure? And 2, what are we learning about behavior change? Maybe 1 question at a time. What are we learning from this figure? Ruby.
Which offer type brings in the most revenue?
Okay, so what we're doing here is going through and adding up revenue by offer type. And in this way, we can see 2 off of 10 is bringing in the most. BOGO 10 is bringing in a lot too, and BOGO 5 is bringing in a lot. What does this tell us about behavior change? Does this tell us that 2 off of 10 is the most effective? I see some people saying no. Someone tell me why. Yeah.
If it's effective, we would probably want to compare the count to the actual revenue to kind of create like an average between the 3.
Yeah, so look, we know 2 off of 10 is definitely bringing in the most. But what if we sent way more 2 off of 10s than anything else? What if the differences between the revenue is simply coming from the fact that we're sending more of some offer types than others? So if I were approaching this, I would think, yeah, 2 off of 10 looks to be effective, but I need to know some extra information. I need a base rate. Like, what's the rate of the offers being sent? So we're going to come to this. But a little bit more information before we get there. We can do a similar thing to what we just did here by event. So if you remember looking at the data set, we had a column that was devoted to just transactions, or just events. The top 5 were all transactions. But I think before we get to this question of base rate, like how often are these offers being sent, we should try to understand the data set in its entirety. maybe there's some extra bit of information that we would want to be able to know how many offer types are being sent. So how many, if you were just looking at the event column, how many rows would you expect? We saw transactions at the top. Would it just be one? Yeah.
Would be 2.
Why would it be 2?
Because you need the offers to.
Okay, so maybe we would send out offers and we would record those. And then we'd also record all the transactions that took place. So if I'm looking at event, I might be thinking potentially there'd be 2. So this figure is just the 2 kinds of categories in the event column. And I'm just going through and counting them. So this is very similar to the first figure we saw, where we were just counting up the number of rows for each one of the offer IDs. Here, we're just counting up the number of offers that were sent and the number of transactions that took place. Okay, so what do we see here? Someone just summarize what this figure is telling us. Yeah. Yeah, nice. We have lots of offers that are sent out. In fact, most of the rows in our data set are not transactions. They're actually offers that are sent out. And we see like 75,000 offers, which is a pretty large data set. And it turns out maybe roughly half of the offers that are sent out turn into transactions. So a 50% like click-through rate, which is pretty high in my mind. I definitely don't use 50% of the offers I receive. I use like, I don't know, 5%. Okay, so it looks like we have a bunch of offers that are not transactions. So to think about the question of like how effective each one of these offers is, we want to not just look at the total revenue by ID, but we want to filter for the transactions that are actually taking place if we're going to get an average. Okay, so what I'm going to do, I think before we get there, is break out revenue by event type, just to confirm what we're seeing here. So you can see all of the revenues taking place with transactions. So if you send out an offer, there's no revenue associated with that, and the row is just left empty, which confirms our intuition for what these rows are actually recording. If it's an offer, it's not a transaction, so there's no money associated with it. Okay. So we're bringing in 0 revenue per offer. And this event column is doing this differentiation for us. It's telling us whether it's an offer that's sent or whether it's a transaction that's actually taking place. Okay, so nice. So this gives us sort of our baseline understanding of what this data set contains. All right, so how many times was each offer type actually sent? So this gives us maybe the baseline to the original question. We have all this revenue that's recorded, but we want to understand how many times each offer was actually sent. So this is that figure. Isn't it pretty? It's like you take the ideas of minimal figures, like take out everything extraneous to the absolute limit, and you get a blank screen. Okay, visualization joke. 3 people thought it was funny, including me. So maybe only two of you. So all I'm going to do is add a filter to the beginning. So you'll remember we'd done some grouping, and then we did some counting and summing. So when we were looking at revenue, we could just add up all the revenue by group. Here, what we're going to do is first filter. So I'm going to look at the event column, filter out everything that's not an offer. So I'm just going to look at how many offers are taking place and group on offer ID. And then I'm just going to count up how many are in each one of these groups. And that gives us this figure. Okay, so I've given you a lot of figures already today, and we have a couple more. But I want you to turn to your neighbor and try to summarize what this figure is telling us. Remember where we are in context here. What we've done is find total revenue by offer ID. But total revenue, you'll remember, does not give us the full picture. It tells us how much each one of these offers is bringing in, but it doesn't tell us how effective each one of these offers is. This gives us some baseline. It tells us how often are the offers actually being sent out. So someone, turn to your neighbor 30 seconds here, summarize this figure in English, and then I'll have someone tell me what you're seeing. Okay. I'm looking for a summary of this figure. What is this figure telling us?
It's saying that the informative, BOGO 5, BOGO 10, and 2 off 10 were like all sent the same amount of times.
Okay. So yeah, this informative, this is like information about offers, I guess. BOGO 5, BOGO 10, and 2 off of 10 are sent the most. So this tells us, if you remember back to our earlier figure, 5 off 20 and 3 off of 7 are bringing in less revenue in total. So what we've learned here partly is maybe part of the relative effectiveness of the BOGOs and the 2 off of 10 is just that they're sent more, which confirms some of our earlier intuition. All right, any questions here? This is a pretty straightforward figure. All we're doing is just counting up how many times each one of these offers are sent. But to do that, we have 3 operations. We first filter for offers. We second group by offer ID. And then third, we just count the rows. So we have generally 3 steps to make this part happen. All right. So yeah, these are some of the conclusions here. But this doesn't fully answer our question, right? These are sort of intermediate steps to get at our main question, which is how much did each offer type bring in on average? And we're going to do this in 2 different ways. So the first thing we'll do is just do a grouping, and then we'll take the average. So we've done grouping and counting. We've done grouping and summing. We can also do grouping and averaging using an aggregation function, which we're going to walk through some of these in the exercise at the end. So if I'm going through and looking at the average revenue per offer type, what I can do is just group by offer ID and then find the average revenue within each one of the groups. So if you're looking at this, try to summarize this for your neighbor. And what we're doing here is not we're not doing any filtering, so we're not filtering for offer or for transaction. We're just looking at row by row everything in our data set. What's the average revenue per offer ID. So let's take maybe 30 seconds to a minute here, try to examine what this is doing, and think about whether there's anything sort of funny looking in this figure. There's a bit of a caveat, and I'm curious if anyone can notice what that is. Take a minute here. All right. Someone want to summarize this figure? And then I think there may be two interesting or unusual things about this figure, about the actual numbers here. First off, just a summary in English. Okay, should I do your job for you? Maybe I'll do your homework for you next class. So when I'm looking at this figure, I'm seeing that there's an average revenue per offer that's pretty similar. It like hovers around, maybe $9.25, maybe up to, $10 or $11, something like that. So there's not a big range in the average revenue per type. A couple of things to notice here. Informative brings in 0 revenue. So there are no transactions associated with an informative offer. These are just little bits of information that get sent out. But I want to point your attention to one particular thing. Look at this. So we have this offer, it's $5 off of 20. So you have to spend $20 to get the $5 off. So how can it be that the average is below 20? Yeah. Yeah, nice. So we have a bunch of zeros associated with this transaction. We're looking at every single row, including the offers and the transactions. And we're just taking the average there. So this includes a lot of offers that are actually not transacted on. Any questions here? So an interpretation here of this figure is that this is the expected value, like the expected revenue that Starbucks will bring in for each one of these offers. So it's like, I send out an offer at Starbucks. How much do I expect to be bringing in for that single ping? And that's what this number is, which is informative to us, but there's a little bit more that we might want. What's another way of capturing the average that we could reasonably set up? I think this is a really good one, but
Maybe
yes.
something like
The median. Yeah, so we haven't talked a ton about like differences between the averages, but median may be a way to go here. Maybe there are just lots and lots of very large values, and median might be able to capture the middle point might be more informative for us in some ways. If we did the median here, though, we would get zeros, right? Because we're looking not just at the transaction the transaction rows, but also the offer rows. Remind me of your name?
Kyle?
Kyle. Yeah, different ways of capturing averages may give us very different perspectives on our data. What else? What else might we do instead of this? We're just going through all of the rows and capturing the average, the mean. Yeah, Jay. So instead of looking at the average across offers and transactions, what if we look at just the transactions? So if we send out this offer, how much would we expect someone who uses the offer to spend? So this is the sort of strange part with what we've done here. We have, this should say 5 off of 20. 5 off of 20 should be above $20 in this case. So here what I've done is just I've filtered for only the transactions, and then within that filtered data set, I've then grouped by offer ID. And then I've constructed an average of the revenue within that offer ID. So 3 steps here. And with this one, you can see we do have an average that's above 20, as you might expect. And I think actually in this case, the median might be a better approach, or at least a very reasonable approach, if we're looking for the middle and not the average. Okay, any questions here? How many of you think this is too many bar graphs that look very similar? Okay, yeah, I like putting these slides together. It's, I think, pretty easy to get lost in which slide we're working with. But hopefully the general structure makes some sense, right? What we're thinking about is how effective are each of our offers, each one of our 5 offers. And what we can do is filter if we need to. We can group, and then we'll do some measuring using aggregation functions, either the accounting or an averaging or a summing. Okay, so I think this is a reasonable way of measuring effectiveness. I also think this is a reasonable way of measuring effectiveness, the average revenue we can expect. So, going back to our original question. Remember the question from the top? Which one of these offers is the most effective at moving behavior? Given these 2 figures, I want you to turn to your neighbor and maybe try to conclude which one of these offers is the most behavior changing. We'll take like 30 seconds to a minute here. This is one of the big questions we have from our data. Okay, some conclusions, maybe some confused looks. Someone tell me what you're seeing. Which one of these offers is moving behavior the most? And what are you looking at? Okay, should I do your homework for you? No, just kidding. No shade. These are difficult things to make interpretations from, especially after seeing all of these figures. First off, I would maybe, we can make some conclusions here, right? 5 off of 20 is bringing in the most revenue when people use it. If we go back to our earlier figure, you can see the average revenue from 5 off of 20 is also the highest. not just when we're looking at the transactions directly, but also our expected return from a ping. So if we're sending out any ping, the 5 off of 20 is the one that brings in the most per ping. So I think this is one way of interpreting effectiveness. And if you think about like basic Econ 101 ideas, what I'm doing is I'm giving you $5 off of your 20. So I'm like taking a quarter off the price, a 25% price reduction, which is a pretty big incentive. So I'm actually giving you a very large incentive, which is moving behavior by a very large amount. So just thinking about your like price elasticity of demand or like movement of price, right? Like quantity is going to respond to a very large change in price. And that's what we're seeing here. And then this was a second picture, which also tells us something, although I would argue potentially less. But I want to walk you through one more thing as I impersonate Steve Jobs. I haven't worn my black turtleneck yet. But yeah, one more thing. Which is, if you don't know, is like classic Steve Jobs introducing the iPhone in 2007. All right. So one thing, in addition to just thinking about average revenue, we also thinking about like how much people change their buying behavior, their spending habits. But in addition to that, we can also think about how much these offers actually change people's decision to actually buy. So in addition to the average revenue per offer, we might want to know what the redemption rate is. Like if I send you this offer, how often are people using the offer directly? Okay, so let's actually do this. So what I'm going to do here, I'm going to filter event, and then I'm going to look at just the transactions, and then I'm going to count how many offer IDs per group. So this is transactions per offer ID. And this gives us a pretty nice picture. This is like how many transactions are happening per offer. And we can see here the most transactions are actually happening from 2 off of 10. So question for you. We're trying to construct a redemption rate. So how often are people using the offer when it's sent? This is a picture of how many transactions are actually taking place per offer. What else might we need? So this is maybe a math puzzle. What else might we need to construct a redemption rate, where we're measuring the probability that someone will actually use one of these offers? So this is a thing you can construct. I'm looking for a very concrete answer. Let's take 30 seconds here and maybe try to construct that. You're seeing this. What else might we need to get a redemption rate? Okay, so here we have our figure for just the counts of transactions. What else might we need to know redemption rates. We need something else. What is that thing? Yeah.
Like an acceptance rate.
Yeah, so here we have a count of all of the transactions, and we need some way of actually capturing how often these transactions are accepted. And what's actually the thing in addition to the transactions that we would need to calculate that? Yes.
Would it not just be transactions, like transactions using offer over total transactions?
Okay, so we're going to look at not just the number of transactions, but we're going to divide that by the number of times the offer was sent. So number of times that the offer was used divided by the number of times the offer was sent. So we have a base, and then we divide the number of transactions by that base. So that's what we're going to use. Here you can see BOGO 5 and 2 off of 10 are used the most. But this doesn't necessarily mean that those two are most effective, like we talked about, because we need to know how often the offers were actually sent. And then we can find this, which is our redemption rate by offer type. So what I've done here is done exactly this. I've calculated the number of transactions by group, and then I've divided that by the number of offers that were sent out by group, which gives us some rate, which it's like how often is the transaction actually used when it's sent out, or the offer used when it's sent out. All right, I've asked you to do a lot of summarization. I have one more for you. If you're looking at this figure, how do we measure effectiveness with this figure? Does this give us a measure of effectiveness? Tell your neighbor in 30 seconds what this is telling us about effectiveness. So, which one of these offers is moving behavior the most? Jay? I'm sorry. Yeah. So, like 3 off of 7. That's a pretty big discount. It's actually moving purchasing behavior by a lot. It doesn't require a lot of spending to get that $3 off. And the $3 off is a pretty big portion of the $7. And then the second highest transaction rate happens with 2 off of 10. And then BOGO 5 is pretty good too. I would say this is a pretty good measure of effectiveness. It's like these things are moving behavior the most. These 3 offers are being taken up the most. But a question for you, maybe my last question of the day. I have 2, I think, pretty reasonable measures of effectiveness here. The first one we talked about, which is like the average return for Starbucks, like how much people are spending on average when you send out an offer, which is this one, so the mean revenue per offer type. And then we have the redemption rate we just talked about, which is like the probability of people using each one of these offers once they're sent. If you're looking at these two figures in total, I want you to come up with a summary for your neighbor about which one of these offers is sort of overall most effective. Which one of these offers moves behavior the most, right? We have two ways of measuring this. Maybe we try to balance these two. What are we seeing overall? We've talked about each of these separately, but I want to sort of sit here with the two of them together to get a sense of overall behavior change. Tell your neighbor which one of these offers is most effective. Okay. If you're trying to classify effectiveness, like the effectiveness of these offers at moving behavior, someone want to try to summarize this? What are we seeing? Darren.
Three also has the highest probability of being redeemed, and also has, or relatively also has one of the highest revenues.
Yeah.
I think something we can also do is find the expected value of each redemption rate or revenue to basically multiply like the chance that they are redeemed by the amount of revenue that they will get if it's redeemed. Basically just giving us the expected value of which one would be the highest basically percentage.
I think the probability is already built into the mean revenue, wouldn't it be? I like the idea. It's like how much do we expect to bring in per offer that we send out? But I think that's exactly what this measure is doing for us, if I'm understanding your idea. So 3 off of 10 is a very high redemption rate, and when we send it out, on average, it's bringing in quite a bit. What else? What else do we see here? Anyone want to make a case for a different, most effective offer? Yeah. Okay, so yeah, 5 off of 20, it wasn't actually redeemed that often, but the expected return per offer sent is actually pretty high. In fact, it's the highest one. So from a Starbucks perspective, maybe that's the better one. It's like, we just want to send out the offer that brings in the most money every time we send it. Yeah. Anyone want to make a case for a different offer being the most effective? I would make a pretty good case for 2 off of 10. If you're thinking from Starbucks perspective, like 3 off of 7 is a really big discount. It's almost 50% off, which that's pretty big. 2 off of 10 has a pretty high redemption rate too. It's not as high as 3 off of 7, but it's still pretty high. This, you can understand this as your basic ECON 101 incentive idea. higher incentives lead to larger changes in behavior. But 2 off of 10 is still a pretty good redemption rate. And 2 off of 10 is bringing in more per ping, per offer sent. So I would say this is also a really good like change in behavior if you're thinking from Starbucks perspective. Okay, so let's just go through and summarize these things. We're economists, at least I am, and I know a lot of you are, or soon will be. If we're thinking about redemption rate, I think 3 off of 7 people are responding most to the best deal. The highest revenue per offer sent, I would say, is 5 off of 10. Right, it has the highest average revenue, but the redemption rate is lower. But if we're thinking about just like how do we change behavior so that people spend more, 5 off of 20 is moving the needle on that margin the most. So people need to spend more to redeem the offer. So the bar has to be higher for total spend. And then the last one, I think 2 off of 10 kind of balances both of these metrics, maybe a little bit better. Okay, so this is just the summary. With all of these figures we created, we did 3 things. 1, if we needed to, we filtered. Sometimes we needed to filter out some of the data by event. Sometimes we looked at just the transactions. Sometimes we looked at everything. And then what we did is we grouped by relevant columns, which allowed us to make really easy summaries. So like these nice figures, we were able to do that simply by grouping. And then once we created the groups, we then applied an aggregation function. Sometimes that was counting, to count up how many rows were in each one of the groups. Sometimes that was summing, so we just counted up how much revenue was in each one of the groups. And sometimes we did an average to get an average measure by group. But we could do lots of other aggregation functions. All right, so we spent an hour talking this through. Maybe we should have broken out into exercises a little bit earlier. What we're gonna do in the last few minutes here is just, I'm gonna show you some of the basics of doing some of these groupings. You're gonna have some exposure to this on your homework, which will get posted later tonight. So what we're gonna do is jump over to our exercise in the last 15 minutes here of class, or last 10. So to do that, you can just drop down here to part 2.4, grouping data, and then you can download the data set. We're just going to do this in in Python for today. I've already shown you the source. Kaggle is just a website for data sets, and there's some code on there too. There are also like competitions if you're interested in like coding data science competitions. But for our purposes, it's a pretty good source for nice data sets like this. So you can click on the notebook. I've already started a few things, just some example code. So I'm just gonna load the data set and then print out the summary, the header. And this is the same figure you saw in the slides. Okay, so the first thing we might want to do is try to get revenue by offer ID. So let's just go through and find total revenue by offer ID. So the way this works in Python, so let's just write out revenue by offer ID. So the way this works in Python, all we have to do is take our data set, so we have data, and then I'm gonna group by, so we have this group by function using the dot notation at the end. And then I'm just gonna write in the column that I'm trying to group by. So this is going to turn the entire data set into a bunch of groups according to the categories in the column that we're specifying. So here we have offer ID. And if you just run this, it gives this really opaque looking object. You can't actually look into it. But what we can do is get a particular column from that data set. So I'm just going to select, using the same notation as we usually do for selecting columns, I'm just going to say revenue. If we run this, it also gives us an opaque object. We have to apply an aggregation function to the end. Now, what I want to do is add up how much revenue is in each one of these groups. So we've constructed a bunch of groups, and we're looking at the revenue column. All I want is to find the total. So I'm just going to apply sum to the end to just count up how much revenue is in each one of these groups, which looks like this. Okay. How many of you were able to get this one? Nice. Do you all like when I put code in the slides? Is that helpful? Okay, I don't have it in the slides currently, but I'll be sure to add that so you can use that as reference material. You can also find this, you can just click on the exercise again to get the code that we're writing in class. So how many of you prefer figures over tables? Hands? How many of you prefer tables over figures? Oh, interesting. I truly do not. So that's interesting that you like tables. Is it because you can see the numbers? Like the numbers are just printed out? Yeah, okay. So sometimes, yeah, tables can give you more information in some cases. So maybe you like this, but maybe you like, you'd like a bar chart. There's a handy little thing we can use with pandas. We can actually skip Seaborn. So I'm going to show you a little bit of an easy way to visualize these groups, which is what I use for my figures in the slides. What I'm going to do is I'm going to call this an object. So we're giving this this table, we're giving it a name. So this is total revenue. So I'm going to give it a name, and then I'm going to have it plot. So total revenue dot plot, and then we're going to tell it to use a horizontal bar chart. A bar with an H on the end gives us a horizontal bar chart. So if I run this, it just gives us the table, but in figure form. Okay, any questions here? And that looks like this. How many of you were able to get this? Nice, love that. Okay, so this is just a really simple way of doing grouping. We can do this kind of grouping and aggregation in lots of different ways. Another one we talked about was revenue by offer, by event type. So another thing we could do is try to differentiate between offers and transactions. So we could do data.group by, and then we have a column called event, and maybe we just group by event. So this would be event, and then let's get revenue, and then we'll sum. So here you can see revenue doesn't ever show up for offers. It's as we talked about, it only shows up for transactions. But another thing we might care about is the redemption rate. This, I think, is maybe one of the better measures when we're thinking about behavior change. So I'm going to construct redemption rate. And this will be the last thing we do. So if we're thinking about redemption rate, we have two kinds of things, right? We thought about a ratio of two different values. Someone remind me what those two values are when we're thinking about a redemption rate. Like, how likely is someone to actually use the offer once it's sent? Someone remind me what those things are. Yeah. Yeah, so we want the number of offers redeemed divided by the number of offers sent. Oh my goodness. So Gemini gives us some code, which in this case turns out to not be quite right, but it's pretty close. So I'm actually going to do this in two steps. So I'm going to ignore Gemini's code. How might we go about constructing the number of offers that are redeemed? Like, someone say this to me in words. Like, what are we looking for before we start writing some code? Yeah, Sabi.
I might be wrong, but the number of transactions divided by the number of offers that we sent.
Okay, so we want to look at the number of transactions that occur by group. And then we want to look at the number of offers that are sent by group.
Right, so like how many of those were actually redeemed?
Yeah,
Using
it's,
this.
yep. Yeah, so nice. So Sabi's saying, let's just look at transactions. How do we do, like select just the transactions? Let's apply a filter. So I'm going to call this transactions, which we're going to filter the data. So this will be data event. And we're going to make sure that these are only transactions. So this is going to be our data set with just the transactions. We can run it just to make sure it works. And then within the transactions, I want to group, I just want to count up the number of transactions in each one of these groups. So this is, say, T count. So this is transactions, we'll group by offer ID, and then we'll just count how many show up. Let's plot this just to make sure. Let's do revenue. Okay, we're running out of time. Something about this isn't working. We'll pick this up next time. We'll finish this exercise and we'll figure out what's going on here. Oh, it's, yeah, we'll pick this up next time. I'll see you all on Thursday. I'll post the homework later tonight and see you next class.